In this video, you will learn how to determine the 4 quantum numbers given an element or an electron in an element. So what are the 4 quantum numbers and how to determine them? Now the 4 quantum numbers are the principal quantum number, which is denoted as n, and this describes the energy level or electron shell of an electron. Then we have the angular momentum momentum quantum number should be denoted as L. This describes the shape of the orbital or subshell and the magnitude of the orbital angular momentum. And then we have ML, or the magnetic quantum number. This describes the orientation of the orbital that an electron is located in. And then we have the MS, or electron spin quantum number, which describes the angular momentum of a given particle or the direction of the intrinsic quantum or spinning of the electron. Now, how do we determine them given an electron of an element? Let's say, for example, we're given here this electron 3d10. So how do we determine the 4 quantum numbers? So to determine the principal quantum number n, this one, okay, the number in front of the electron, this one, this is the principal quantum number. So n here is equal to 3. And for the value of L, this depends on the regions in an atom where electrons are most likely to be found, which are the SPDF orbitals. So L is equal to 0 for S orbital, and L is equal to 1 for P, L equals 2 for D, and L equals 3 for F. In this case, we have D here, therefore the value of L is equal to 2. And now for the magnetic quantum number, or the ML, this one depends on the SPDF orbitals. So for S with L equals 0, ML here is 0. And for P with L equals 1, ML here is could be -1, 0, and 1, because it has 3 orbitals. And then for D orbital with L equals 2, could be, the ML could be -2, -1, 0, 1, 2, because this has 5 orbitals. And for F, which with L equals 3, ML could be -3, -2, -1, 0, 1, 2, 3, because this has 7 orbitals. And this means that the S orbital has only 1 sublevel, because it can only hold up to 2 electrons. And then the P orbital has 3 sublevels. Then D has 5, F has 7. All right. Now, since in our given electron here, we have D orbital, so that means L is equal to 2, and the values for ML could be -2, -1, 0, 1, 2. So we have 5 sub-levels. So the values could either be -2, -1, 0, 1, 2. And each of these sublevels can hold up to 2 electrons. And now we're dealing with 10 electrons here. So we fill in these sublevels, right? Okay, so we draw arrows going up and fill in these sublevels. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we fill in everything. Now we've already filled in all the orbitals with 10 electrons, and then we stopped here. So this is the last electron that we filled in, and it landed on the 2 orbital. Therefore, the value of ml here is equal to 2. Now let's find the ms, or the electron spin. So how do we identify that? Now for the electron spin, or ms, there are only 2 values, positive and negative. Positive 1/2 or negative 1/2. It depends on where the arrow is facing. If it is facing upwards, then it is positive. If it is facing downwards, then it's negative. Since the last arrow here that we filled in, or the last electron, is facing downwards, so that means the value of the electron spin is equal to negative 1/2. Alright, now let's try solving this problem here. What are the quantum numbers of the 22nd electron of iron? So before identifying the 4 quantum numbers, we need to write the electron configuration of iron up to its 22nd electron. Now iron has 26 electrons, and we are only asked to determine the quantum numbers of the 22nd electron of iron. So let's write the electron configuration of iron first. Okay, so that would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Let's check if it's 26. 6, 12, 18, 20, 26. All right. So we're only asked for the 22nd. So we count the number of electrons up to the 22nd only. So we have 2, 4, 10, 12, 18, 20, 22nd. So we remove 4 electrons from the last electron. So this would be 3d squared, or 3d2. Then we will only use that part. So we have 3. Where is that? Now for the principal quantum number, n here is the number in front of this electron. So n here is equal to 3. And then L, the value of L depends on the orbital s, p, d, f. So when it is an s orbital, then L equals 0. For p, L equals 1. Then d, L equals 2. And then f, L equals 3. Since our electron here has d orbital, therefore the value of L is equal to 2. And then for ml, the value of ml, when it is an s orbital with L equals 0, the value of ml is equal to 0 with 1 sublevel, because it can only hold up to 2 electrons. And then for p with L equals 1, the values for ml could be -1, 0, 1. and it has 3 sublevels. And for d orbital with L equals 2, the values of ML could be -2, -1, 0, 1, 2, and it can hold up to 5 sublevels. Oh, it has 5 sublevels. And then for the f orbital with L equals 3, the values of ML could be -3, -2, -1, 0, 1, 2, 3 with 7 sub levels. Now let's determine the value of ML. Alright, we're dealing here with 2 electrons because we are only asked for the 22nd electron of iron. So for d orbital, ML, the values of ML could be -2, -1, 0, and 1, and 2. But we only have 2 electrons here, so let's fill in the sublevels. So we start with arrows facing upwards, but it only has 2 electrons, so 1, 2. So these are the values of ML: -2, -1, 0, 0, 1, 2. So the last arrow, or the second electron, stopped -1. Therefore, the value of ML is equal to -1. And since the last arrow is facing upwards, therefore the spin, or ms, is positive, and that is positive 1/2.